Alrighty. Still going through some setup, sorry. What is that? Oh, I see. Okay, let's fire stuff up. I have not looked at any of this in a week, which is great. There we go. Projects. Right, okay, so I have these token files here, and I actually started to rename them as Lexa, because that is what it is. I think token might be a bit confusing, or tokenizer. So I added that in here instead. Now, the other thing I did is I kind of before had these parse hexadecimal and parse binary and parse decimal. I had them in the parser file, which is not really the concern of the parser. I instead want it to be returned as a token. As you can see, the token now has a length and a union for values, so it can either be a number, a string, or a keyword. Oh dear, I'm so sorry. That is the last thing I remember doing. I basically... yeah, I basically wanted to have a way to attach values to tokens, so I don't have to do this in the parser the whole time. My keyboard was still connected to the other machine. Fantastic. And there's also now an invalid token type, which is basically... Morning, Kakalak So invalid token type is just something to handle errors within the tokenizer, or now called lexer. So if anything is wrong with a number, right, I set this token type to invalid, and then basically return an invalid token. That way in the parser, when I then see an invalid token, I don't need to print out another error because I know the tokenizer, or lexer rather, has already taken care of it. And I can just ignore it and completely stop parsing for this line of code because, hey, there's a bunch of invalid stuff in there, right? So I'm doing that now. Sorry, I really have to refresh my memory what else I did. So, more helper function for code point checks. Right, I now have like is hex digit and that kind of stuff. Removing ASCII character token. Yeah, we didn't need that. This was adding the original parse. But then I have this first attempt at the new lexer. Okay, so let's have another look at the new lexer then. What have we done so far? We have this, right? Is code point end of token. That one is new. But then read end of token. We have a read white space. Right. We have a read comment now. So I kind of separated these out a bit more. And then right, I do not have read end of line. Why don't I have read end of line? Oh, because I only used it in the comment, right? So this is why I now have read comments to, like, you know, be a bit clearer on what this is supposed to be doing. Okay, so basically, I should also zoom in, sorry. Again, completely not prepared. I have been gaming quite late into the night. Completely forgetting that I had to stream. I just needed a little gaming session. Anyway, so... Okay, let's just translate this over, right? So this is just read token, where we read a token from a source file. So let's just copy this into the lexer. Okay, so again, the only reason why I'm now renaming this lexer is because I wanted to have it perform a little bit more work, and this token.c is a bit weird, so... Okay, so we pass in the source file, token, line, column, and position are still the right thing. But then we have length, right? And then we have a union of values, which will be filled in. So this no longer happens, right? So this still happens. We get a code point. What did I do for decimal? Okay, if it is end of file, we just set the token type to end of file. That is fine. Token. I don't care about the value really, so I just leave it out. But we have to swallow the code point, right? Actually, do I need to swallow the code point? Because get code point. I mean, end of file is end of file, right? Let's not swallow it. But then there is white space. Then I have this read white space, and this one gets and swallows and sets the length accordingly. Superb. Okay, and is also doing the setting the token type. Okay. No. Yeah, no, token. Okay. So we got this covered. I mean, I could swallow the code point beforehand, right? Because this would then parse it twice, but I don't think that is an issue really. Let's just do it. Let's just be nice. Right. Okay, so is code point digit. Now, this would go into read decimal. So I definitely have to read the first number twice. So I'm not gonna swallow, but read decimal. And that's just gonna be file token. Okay, cool. Okay, and then with all of these next ones, I know they're all prefixes, right? So I can definitely swallow beforehand, because, yeah, I don't want this token to appear in any of the values. And then I can just copy this switch statement right here. And we no longer need this. Right, okay, cool. Comment has just now read comment, right? Token. And we no longer need to do this separately. Do it this way. Token type, comma, +1, divide, multiply, blah, 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 blah. Okay, that is fine. Actually, we're going to set the token length to at least 1. Because most of these will just be 1 character long, right? So, and then if they're not, like with read comment, for example, they will calculate the new length in there in the end anyways. Okay, hexadecimal becomes read hexadecimal in file. Let me just verify what I wrote. Again, it has been a week, so I have no clue where I left off. Actually, a bit longer than a week, hasn't it? I don't know. No, a week. All right. Okay, this straight goes into trying to pass the hexadecimal digits, right? And if anything is wrong, it will say token type invalid. Now, here's the thing. Oh, no, okay, I do have read end of token. I'm not sure I like the way I did it in here, but I mean, if it's already in there, it's fine. So if there's an invalid character within any of those, you know, hexadecimal numbers or binary numbers or decimals, right? Then I set the token type to invalid. But I still need to pass the rest of the sequence, right, until we reach the next token. So this is why I have this read end of token. And that basically just reads any character, swallows it, until it reaches a new token, essentially, with is code point token. So there are all the tokens in here. Okay, so no longer need this. Right, ooh, jeez, what did I do here? Okay. My dog is going crazy right now. Okay, this will become read binary. Doesn't this look much cleaner right now? Wait, read binary. try and read binary. I said the number. Good. Good. That is what I had to double check. Okay, we have directive, except I have not implemented these yet, nor do I have implemented any of these. So we have read hexadecimal and read binary. And those will give me the numbers. Then let's make the default case for now, before I go into any of these, because I have to think about these a little bit more, right? Actually, fine, let's leave default right here. No point in shuffling it around. So what I did before is I read to the end of the token. Then try to figure out if it is a label. And if not, I try to figure out if it is a keyword. So, and now the keyword value can actually be stored in here. And if it is a label, it will just be the string right here. For string, the length doesn't really make sense, but I'm essentially encoding the length twice. No, but that's okay, because when we go into strings, we can leave out the quotation marks, and the length would be, you know, the true length with the quotation marks, while the string value is just the string without the quotation marks, so we don't have to worry about that. Because the lexer will now take care of giving us either a valid string value, right, or it will return invalid. That is the change I wanted to do, just to keep the parsing code simpler. So by parsing code, I mean the code where we build, you know, the syntax tree. So actually go through the expressions, build our expression tree, and then parse the expression tree, right? Okay, so read end of token seems to be what I want, right? I already swallowed the first code point here. Okay, so read end of token. File token. Wait, no, it doesn't have a token. No. Well, that's exactly the thing that needs to be done then. And it does not set the length. No, it doesn't do anything with the token. Maybe I should rename this one. Skip until end of token. Because that's essentially what it's doing, right? It's not validating anything, it's not doing anything, we're just skipping until the end of the token. So that name makes more sense. Okay, and with this we set token length to, let's do exactly what we've done here. Actually, I want this in a separate function as well. Read identifier, right? Keep it clean. And not in the code, clean code sense of clean, but rather just, you know, most of these will probably be inline anyways, so it won't be happening much. Yeah, all right, you shut it. All right, there we go. Okay. So the default case is now just read identifier. That reads a bit nicer, right? So we skip until the end of the token, and then we say token length is this one. And then we check the next code point to see if it is one of these. That's fine. And then token type, then it becomes a label. But the length is now wrong. So token length +1. Now, see, this is why I like doing the length at the end. Oh, I actually do it at the end there. Okay, fine. Do I need anything else if it is a label? Yes, I do. I was just trying to figure out if I can combine this because I also need it for the identifier. Basically, I need to set the string value now, right? So I added this string to the token. I mean, that should work, right? So I can actually do token string, right? base equals file it's base token position. Let's get the address of this. And then token string length is, it's gonna be this. Because for the label, we want it without the colon at the end, so we can just set the string base and length like so. Then if it's a label, set it to label. Swallow that. And then go to token length, right? Okay, this is fine. So then the else case, we're trying to figure out whether this piece of string that we have here is actually a keyword, right? If it is a keyword, then we set the token type to keyword and the token keyword to keyword value. And it kind of invalidates this, essentially. And then we still want the correct length, right? And if not, it's just going to be an identifier. And we've already set the string for this. This seems correct to me. Okay. Cool. So we have this read identifier now, and now we can look at the other cases, essentially, before we plug this tokenizer in. But you know what? You know, since I'm not using these right now, I'm going to ignore them. And let's just plug in the Alexa. Okay, so keywords. It only relies on memory arena now. Hash map entry. String literals. Right last window error and exit. Okay, so it doesn't have a lot of dependencies. Okay, cool. Because I also dislike this include here, so okay, let's copy this one in here. Read token excluding white space. Right, yeah, okay. So this is where we want the actual Alexa to happen. I think this way of doing it is still alright. I don't think I need to look ahead more than once. Famous last words. Hopefully I don't need to look ahead more than once. At least twice, yeah. Okay, let's take this one. And this will be Alexa. Memory arena is still okay. We have the source file, and for some reason I attached the output binary, but that is not part of the Alexa. So I'm gonna ignore that. All right, let's keep it simple. We put the Alexa onto the arena. We set the file to file. We don't need these. And then I have read token excluding white space, right, for the current token and the next token. That is okay. And this is now called Alexa. Okay. Don't need this. I might want this. So let me just plug it in here, but comment it out for now. And we can delete this one. Yes. Okay. And then read token excluding white space. Okay. We do the read token. And if we get a white space or a comment, we're just going to ignore it. Yeah, that's all right. Nothing we need to change there. And then tokenizer advanced. So that basically means geez. So this was swapping the current token with the next token, and then read the next token with excluding the white space. I think advanced is okay. Okay, delete file. Okay, cool. So we have a new Alexa. Let's dump that in. So string, hashmap, console, error. This all still makes sense. Source file, ROM file, okay. Then we have keywords, fine, stats. It's also such a stupid name, to be honest, but okay. Yeah, that doesn't matter. Stats, it is what it is. And then Lexa. So these symbols. Actually, let's make this compile first before I think about the other thing. Oh, did I not close you? Forgot to close a few things. All right. What? What do you want? Windows security actions recommended. Fine, do your thing. I don't care. Right, let's make it compile, right? So this will be Lexa. Don't need the output. Lexa T. Lexa, right. Fail to create Lexa for file. Parse source file, Lexa. Okay. Now this will be Lexa T, Lexa, right? And then Lexa T, Lexa. No, I hope it doesn't do a reboot. Nah, it was just a quick scan. All right, cool. That would be funny if it actually rebooted. Okay, so we also no longer need these, right? Because the parsing of these numbers now happens in here. Right, and I should retest these. But I do not need to parse anymore. All that I need to do... Okay. Is print out the parsed value, and that will now be stored in token number. Token number. And token number. Okay, let's remove keyword for now. New line, yeah, that's still fine. Label, let's not do that for now. Right. Actually, case token type label and token type identifier. We can then say strt message equals string format in the arena, parsed value, %.s. Wait, is it star.s or no, .s? I always get this wrong. And then we can say to actually, I do have a thingy, don't I? The string to format args. So token string. And then write output string message. Right. So we're just going to print out whatever identifier and label we read. And token type keywords. We're gonna do sort of the same, except we have to look up the keyword, right? But we have the keyword value, and we also have access, which is a bit hacky, but we have access to the keyword data, right? So there I can then look for the entry and the key and just print out the key. So let's do that. So G keyword data would be okay. Great spam. And of course the spam follow finishes my follow goal. Bye. Anyways, so here we can then say token keyword, right? Because all the keyword values, which is just a number, also corresponds to the same slot in the keyword data, right? And then I can just say keyword data dot entry dot key dot entry dot key. So that is our string. So parsed identifier. Actually, I'll make it two separate ones in a second. Parsed keyword, and then just this, right? And yeah, let's make a separate one for label. Parsed label. Parsed decimal. Parsed hexadecimal. And parsed binary. Oh, except I haven't changed decimal yet. Hang on. Right, so this becomes this. Hexadecimal. And this becomes decimal. Okay, so Alexa, fetch the current token. If the current token is not equal to token type end of file, then try and print out what it is, except if it is a new line. We don't care about new lines. And It's alright, don't worry about it. I have no idea about the mod interface either, so it is what it is. Oh, it's alright. Okay, another thing we could now print out. Why is this so complicated? Genuinely, because most people that work at Twitch probably do not use Twitch themselves. I'm saying that's obviously a claim, right? I have no idea of verifying this or whatsoever, but in my experience in the software engineering world, in all the companies I worked and things like that, most of the programmers do not use the products that they're working on, which is why you have some weird, confusing things happening because they don't think about like proper use cases and things like that, right? Also, they generally do not talk to customers. If someone talks to customers, it's just the product manager, right? And the product manager usually has no idea what the fuck they're doing. If any product managers out there feel offended, so what? I generally have not found a single good product manager in my career whatsoever. Never. Because usually those product managers also do not use their own product. Yeah. This is when you... It does explain a lot. It really does. Like, you have no idea, like... You know, I try to always think with the user in mind, and I did so in my previous jobs as well. And every time there was a feature, I was like, okay, but why do we do like this for the user? Because it seems easier to do this and this and this. And generally, it would just, be ignored by the product managers because they're like, no, this is not what we do. The customer just wanted this, so let's just do this. Zero thought put into things, but whatever. Right, so I was thinking, now that I have the invalid type, so in read binary, for example, so we encounter an invalid character in the binary, we set it to token type invalid, and then skip until the end of the token. I was thinking I could populate the token string as a value for these, but actually I do not need to do that because I know the token length, right? So I can just print out that. Yeah, so now, shut it. What's with all my alarms? Why do I have so many alarms today? have one at 12, which is for the coffee. I should leave that. Okay, 1 alarm every hour. Fine. So now we can say token type invalid, right? And print out that one. I mean, this is all just printing out test stuff, right? So invalid token, and then we can just say you know what? We can just say token length and token, no. It's in the Lexa, right? Lexa file base token position. There we go. That's what we want. And probably the address of it. So this is the start of the token, and then we have the token length. We also have this with invalid tokens, so we can just print it out. Okay, and I'm not going to worry about all the other tokens right now, because that is a thing for later. And we do not have a default case for now. Okay. First build of the day. CD projects GD assembler build. That scares me. Code point. There we go. What is an assembler? I really should make that video. So an assembler is a very low-level language for specific CPUs, right? Directly for CPUs. So every CPU on every device has a specific instruction set that you can use, right? And those instruction sets are usually encoded in a binary format. But it would be quite painful to type out that binary format, so the first abstraction away from it is assembly language, which is just these little, mnemonics, basically. So LD stands for load, and then you have like some operands and stuff like that, and that will generate a specific byte instruction for you. Is that the language where I do like jump or whatever? Yes, exactly. So JP is jump, for example. This says jump on a specific condition to wait for v blank, right? So this would jump to this address label right here. And the code is basically just written top down. So the CPU would then execute this statement first, this second, third, fourth, fifth, and then if it needs to jump back, it does that, or it jumps forward if it needs to. Yeah. And an assembler basically takes this text file that you have right here and creates binary output. You need 2 minutes? Okay. I am requested, so I'm going to take a 2-minute break real quick. Give me 1 second. Man, I should have shortcuts for these. Okay, I'll be back in 2 minutes. Mike, I'm back. With my dog on my lap, I had to kill a spider. My presence was requested to kill a spider. And I hate spiders myself, so that was fun. Anyways. Okay. Where was I? Parser C. I gave an I gave an explanation of an assembler. Okay, and now we can actually fix some stuff. Okay. Right. Right. There is no result. There is token. The brave hero returned here. I mean, whenever I have to deal with spiders, I let out squeals that are not really heroic. Let's put it this way. Right. So this result. This is also not result. Did I name this result everywhere? Oh, gee. Yeah. I forgot the asserts here. Assert token. Okay. Build. What? Okay. What's wrong now? Code point. Yeah, that will be U32 code point. Thank you very much. That should remove some errors. Cool. Cannot convert void star to keyword type. Keyword value is void star. Excusez-moi. It is not. Hash map. Oh, yeah. Yeah. It is void star. No, you're absolutely right. Oh, gee. Now I lost the plot. There we are. Right, so this is gonna be keyword type T, right? Because it is a pointer, but then we want whatever the pointer is pointing to. So we do this. Okay, symbols. I haven't changed anything in the symbols. What are you on about? Have I? No, I have not touched... I have not touched symbols. What do you want from me? That should be clean. Oh. Yeah. This is what I hated when I did it. Let's just comment this out for now, shall we? Parser. Parse instruction. Yeah, we done. Okay. What? Oh, right, it needs the memory arena now. Output. Local variable is initialized but not referenced. Yes, and that is a warning anyways. That is okay. But we have a few warnings in the Lexa which I want to get rid of. Assignment within conditional expression. I freaking hate this error. I hate it so much. So what? That is intentional. Okay, I had enough of this one. I'm gonna disable that warning. WD, but do you need the C as well, or is it just WD? You don't need the C, okay. So slash WD, whoops, WD. There we go. What, you want to go to the bed now? Am I moving too much for you? Okay, there you go. Go to the bed. Okay, and now you wander out of the room. All right, 1 second. There you go, mademoiselle. Don't be a stranger. She never knows what she wants. Actually, no, she doesn't know what she wants. Oh, whatever. Okay, cool. So we have lots of output, which is great. There we go. Identifiers, right? We have hexadecimal values, apparently. Okay, this identifier is empty, which is curious. Label, which is empty. What is going on here? What is that? What? Okay, I think so keyword is fine, right? And then some identifiers are fine as well. But what's going on here? Okay then, read identifier. build, run, debug. Parse source file, and let's go to Lexa Advance, and let's go to read identifier, and yeah, that's fine. And of course, I do this again. I need to be in this folder. Thank you very much. Right. File base token position. What? Can I not specify a length? How does this work? Oh, come on. Needs to be an address and then array of 2. What? That's a new line. Why are you here? Wait, did I remove the new line handling? And I didn't realize? Come on. No. How do you do this? You know what? Let's just look here. Parsing. Token. Yeah, I did remove new line handling. Whoops. Okay, that explains a few things. My bad. So if code point is new line, then we set token type to new line. And we don't have anything special for new line. Which means we can swallow the code point and this is a tiny bit annoying. I have to do this in here. Okay, that looks a little bit better, except it doesn't. Like, what are these empty identifiers here? Let's check. So before alias, right, we have a few comments. And for some reason, you think those are identifiers. Now, why is that? Did I forget something else? No, comment is right here. So let's check Lexa. Swallow code point. This is a comment, right? Okay, let me remove the number parsing for now. Parse keyword, parse identifier, label, da 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 da. Okay, so let me comment these out. Oh. Well, you look at that. It seems to be an issue with numbers. Okay, let's just add decimal. Hexadecimal. Binary. What? Was I still running old stuff? What? Yeah, probably. Oh well. Okay, and anyways, what I want to try now is to do the numbers again, right? So 1, 2, x, 3, 4, right? Then let's do AB, AX, ABCD, AX, CD, A, B, C, D, E, F, right? That's way too long. This will probably work, to be honest. I mean, yeah, invalid token this one, but why do you stop parsing? Interesting. Seems I screwed something up in the error. Wait. Why? Why is the length 7? Oh, so it's in read hexadecimal. Sorry, line 7. So this one. Okay. Right. So this is the case when the passed in hexadecimal is bigger than what's allowed. And at the moment, the Game Boy only knows 16-bit, right? So any address bigger than that is bogus. So I wanted to return it as an invalid token because, like, what are you doing, right? You can't jump into an address that doesn't exist. So this case is all right. So it has the number here, and it is bigger than the allowed value. It sets it to invalid, but then fails to add the error. Ah, I see it. I see it. I see it. I see it. So that will probably be the same issue on the other ones. This is all right. I need the pointer. So the address of this. This is okay. The spammers are on a roll today. Okay, here I need the address as well. And here I need the address as well. Okay. That looks more like it. And now I actually have error messages. Cool. Okay, cool. So, program. Let's see. So, line 2 is an error. Column 3, yes. Invalid character 78 in decimal value. Well, I don't like that. What the hell is 78, right? I think I just printed out the hex. Yeah, that's the hex. Ah, that's okay, don't worry. Can repin it. To be honest, it still shows as pinned for me, so it's probably fine. Let me check the channel like this as a new viewer. Yeah, no, it's still pinned. Don't worry. The magic. Okay, so I'm going to put a percentage sign in front of this to indicate that this is indeed a hexadecimal value, because in this assembler, hexadecimal values are prefixed with a $sign. So I'm going to do the same thing in the error messages. That just feels natural. Let's put it this way, right? So, whoa, I still have been in the wrong PC. Okay, there we go. And here as well. Here. Yeah, I already did this for the source file UTF-8 errors here. Okay. Okay, build, actually, let's clear the screen, build run again. There we go. At least now we know it's hex 78, right? And then we can kind of figure out what hex 78 is. The reason why I don't want to print this is because it could be something that cannot be printed, because it is like a byte that's whatever, you know, like a control character or whatnot. So I'm just going to do that. Invalid character, hex 78 in decimal value, only 0 to 9 or underscores are valid characters, right? So decimal so-and-so exceeds maximum allowed value of 65535. Yep. Then, sorry, I should actually show this. So this has been reported as invalid. That is cool. Line 3 has been reported as invalid because it's too big, right? Then we have line 6 and 7, which are errors. Exactly, because this one has an X in there, right? Invalid character hex 58 in hexadecimal value, blah, 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 blah. What the hell did I do here? Oh, I see. Okay, and also I should add the same thing for binary. Hang on. There we go. Well, and now we screwed something up again. Right, yes, we did. I just realized what. This is not needed then. Right? And the same probably goes for read binary. I was printing out the token before, but I don't need it because it is already a valid token, right? it is just bigger than UN16, so I do not need to print out the token prefix because the string already includes it that I'm going to print out. That's why the double string was there. And this one doesn't have a prefix, so that's why I didn't notice. Okay, yeah. Okay, so line 7 again. Hexadecimal ABCDF exceeds maximum allowed value of FFFF. That is correct. Then line 10. Invalid character 32, yeah. In binary value, only are valid characters. Okay. I could probably add something to print out, like if it is in a valid ASCII range, I can just print out the ASCII character. Otherwise, I print the hex code. That might be a good idea. Okay. I'm not going to do that now, though. Okay, and then binary blah, 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 exceeds maximum allowed value of... Oh, I do have the hex in there. Can STB print as binary? I don't know. There's a B there, so maybe it can. You can print integers in binary. Nice. Okay, let's do that for read binary instead. What's a capital B then? Okay, and what's a lowercase b? Is there any difference? There doesn't seem to be any. Okay. But I want the token here. Yeah. And on read hexadecimal, we want the same. Just if you change the tokens so you don't have to go through this and change them in here. I'm just gonna print out the value of the token like this, which is the prefix. Okay, right, and right here. Okay, cool. And then let me clean this and then go to the very top, and then we can actually verify that those are correct, but I think they are because I just copied that code right from the previous implementation, which I've already checked. But There we go, parse decimal. We have the invalid tokens right here. Then we have parse hexadecimal, right? Which ABCD is probably this value. I don't know. Should be. ABCD, right? It's 43981. Yeah, there you go. Then again, follow two invalid tokens. We have a binary, which is that, which is probably correct. 1365, yeah, there you go. And then invalid tokens again. Okay, cool. Now, I was debating whether the... Actually, let me commit this. Okay. Yeah. Authentication failed. Every time I push, the first time the authentication failed, and then it just works again. This is a private Git server, by the way. I still haven't made this public for backers on the Ko-fi page, but I'm working on it. There's still access to like the previous source code before Alpha 4 in zip files in a Dropbox, essentially. But I do want to make this available for Ko-fi backers soon. I just need to figure out how to properly deal with the reverse proxy and how to deal with accounts and account verification and this kind of stuff. So it still takes a while. First time I'm setting up this server, so... Okay. Cool. So one of the things I was wondering is in the Lexa so dealing with identifiers, no, that's actually okay. Never mind. Directives and labels are already different. So identifiers really will just be names that need to be resolved, but the resolving of the names should not happen in the tokenizer. That is not the job of the the Lexa. I always called it a tokenizer all the time, but no, Lexa. Okay, I think I can start with pausing expressions. I don't want to deal with symbols yet and stuff like that because this kind of annoyed me as well. I kind of need to think about how to rewrite this, but I want to start with the smaller chunks first, right? So let's try that. So what we want is expressions, right? So expressions, I think I have them in here, right? So the most simple ones, subtraction, addition, let me think about it, how to do this. I'm just going to put it into the parser file for now, but I will probably have a separate file for it eventually. So, okay, so basically we have a statement, right, which is the whole line of assembly code. Right? The statement can have an instruction which is followed by operands, right? And an operand is essentially an expression that you can build up. So so an expression can have a left node, right, and a right node. Essentially, so let's say we have a plus b, right? Let's deal with addition first, right? So we have a plus b, and what you have is you read the well, what I essentially want to have out of it later on is I want a node that is for the plus, right? And then the left node would be A, and the right node would be B, right? So basically like a binary tree sort of thing. So maybe no. Okay, so this thing right here, a single node, can have multiple types, right? So it could either also be an identifier or an immediate value. Or it could be a register or whatever. So let's not worry with numbers for now. This expression will annoy me, so I'm just going to name it node for now. Great. Let's just call it node. And then I change the name later on if I need to. Whoa. And this would be node type enum. I'm also too lazy to type, so whoops. So a node type. A node type can be an immediate, in which case it doesn't have a left and right, but it has but it has a value, right? And the value, well, usually would be a number, similar to the token right here. I'm wondering if I should just attach the token. Nah, I probably don't want that. Although I do want to report line, column, and position and stuff, in case something goes wrong. Anyways, let's just do this, right? So that's the immediate value. And Okay, I need to think about this a little bit, and I also need a coffee. So I think I'm taking a 5-minute coffee break. And while I make my coffee, I'm going to think about this a bit. Because essentially, I want to pass the left node first until I get a node type like add or subtract, right, or divide. So any of these are like binary operators, right? So, and then we also have and or X or and not. So those are all the things that can be the root of a tree, right? And then either left and right is either more of these, right, depending on precedence, or it is going to be an immediate value. Or later on, it's also going to be a symbol or whatever, but let's not overcomplicate this. I just essentially want to be able to have these in a row. Need to think about precedence a little bit, but I first want to get the parsing the left and the right thing right. Okay. Okay, anyways, 5-minute coffee break. I'll be back, and then we'll dealing with this. All right. Let me do this. All right. Okay, see you in 5 minutes. All right, I'm back. So, did I unmute myself? Yeah, I did. Okay. One thing I could do to make this a little bit easier would be to check out a video by Jonathan Blow, because he and Casey Muratori, I think, have talked about operator precedence and how this kind of parsing works. But where is the fun in that? I want to try for myself first, and then, always give it a go myself first. Whoops, I'm in the wrong PC again. Also, I'm curious about this one. I forgot about Modulo. Okay, but essentially this is C precedence list, right? Which this is the highest precedence because you want multiplication happening before addition and subtraction, right? And they have a whole bunch of other things here. We do not have logical NOT. Because we also don't have logical operators, right? We only have bitwise operators, like these. Okay, well, let's just start. Let's just make a... Right? We don't know what we need yet. We're just trying to hack it out. I couldn't see the chat for a second. There we go. Right. So let's just call it, actually, parse node, right? Whatever. So what do we want to start with? The first thing we want to start with is, well, we probably need the lexer. That is true. And we probably want the current token. I just realized something. I might have to have more tokens to look into. So we're already ignoring white space and these things, right? Let's actually start with this. 1 plus 2, right? So 2 immediate values. Could be binary, hexadecimal, whatever. It doesn't matter, right? We're already ignoring white space. So what we would have is this, right? So very concise. There could be a plus in the beginning as well, but let's not get into that. For now, let's just do the basic case, right? So we have an immediate value first. So we look at the current token. That is gonna be the... Oh, sorry, I bumped the mic. That is gonna be the left side, right? So this would be 1. Then we want... That will be 2, right? No, that will be plus. I'm sorry, I'm being very quiet because like, I'm trying to run through multiple scenarios in my head right now, which I know doesn't help for streaming. um, So really you want to parse left and right, right? So let's pretend this is either left or right. Essentially parsing a leaf, right? And you want to get the next token and check what it is. See, in my head, I'm already trying to like think about things like, you know, these things, right? So if I have something like this, but maybe I shouldn't worry about that for now and just build on top of the basic foundations. So really what I want to know is if one of those token is one of these operators right here. Right? And if it is one of these operators, then I know it is the root of something, and what I passed before is the left side, and what comes after it is the right side, right? So I need to be able to identify these things. So let's do that. So maybe B32 is binary operator, right? And maybe we can pass in a token. And oh, this is okay. Switch token type, right? And then on a few token types is token binary operator. Let's put it this way. And token. So token type plus, token type minus, token type divide, token type multiply, oh yeah, we don't have modulo because the percentage sign is for binary. Whoops. Oh, that's okay. I don't even think we need divide and multiply, to be honest. Mostly you just need plus or minus, but I just thought I add them as convenience. But maybe that will just make my life a living hell, right? So we'll see. Okay, and then we have case token type or and not and XOR. I'm not dealing with left shift and right shift just yet. Maybe I should though. Let's just set them to the same values. Oh, really, instead of that, I can just say operator and then store the token type, to be honest. Instead of having like this huge enum there. Maybe that's a better idea. So I just say node type operator. Binary operator. I'll just comment it out just so I don't lose it in case I change my mind, but I think that is maybe the better idea. And then you can say something like this. Token type, the operator. I could also just add it to the immediate, to be honest, but it's fine. They're both U32 anyway, so it's fine. Okay, so plus, minus, divide, multiply, or, and, not, X, or, left shift, right shift, in which case B32 true, right? Otherwise, whoa. Return B32 false. Is token a binary operator, right? I wonder if I should even do this with pointers right now, or just put everything on the stack and just copy stuff around. Okay, let's return 0 for now. And I think I have one of these. Yeah, just not implemented. There we go. Right, of course. What? Ah. Okay, that's better. Forgot the semicolon there. Okay, so right. So at one point, I'm gonna have a token, right? Whatever this one is, doesn't matter for now. And I'm gonna check, is token a binary operator? And if it is, right, so here, pass left side. And if this is a binary operator, then I want to pass the right side. Actually, hang on. If it is not a binary operator, then it is just like one of these values, right? I'm not going to worry about brackets just yet. So if it is none of these, then it can only be an immediate for now. So really what I want So if token is not a binary operator, then I want to just I need to figure out what token then is, right? And okay, let's do let's make a parse immediate, right? So at some point I'm gonna get a token. Right? And this one is going to be an immediate. And we know it's going to be an immediate if it is, well, one of these. Hexadecimal, binary, or decimal. Later on, it could also be an identifier, which we then need to try and resolve. But we can either resolve it and it becomes an immediate, or we cannot resolve it, in which case this whole expression becomes, this whole statement becomes faulty anyways. Or we need to defer parsing it until sometime later. And when it comes to these binary operators, you can only really do this with immediates, right? Everything else doesn't make sense. Because, like, what does it mean to, like, A plus, like, a register plus something, right? That doesn't work. We don't know what A is. A is, like, that will kind of go into meta programming and trying to make sense of the program flow and trying to figure out what is in register A and stuff like that. That doesn't make any sense. So we only deal with immediates here. So it has to be an immediate. Well, it is an immediate or a register and stuff, in which case it would be a keyword. And thus are not allowed in binary operands anyway. So, okay. So we expect an immediate at some point, right? Where was I? So, and an immediate can either be token type decimal, token type hexadecimal. So I don't know why this editor keeps doing this with formatting cases like the way it's doing, but certainly annoying. Okay, so it can be a decimal, a hexadecimal, or a binary, in which case it is fairly simple to translate it into an immediate node, right? Because we have the value. That is just perfectly fine and dandy. And then there is special cases of, well, what if it is a token type identifier, right? Because then it might be a variable or an alias of some keyword that we have, so we kind of need to figure out, like, to do try and resolve identifier, right? Then anything else is regarded as an error, right? Okay, parse immediate is wrong in this instance, but like, okay, I'm just trying to get through all the stages right now. So, okay, decimal, hexadecimal, and binary are an immediate. We have an identifier, which we can try to resolve. And let's call this one parse node. Okay, so let's put it this way. We can call parse node with the tokenizer current token, right? Whoops. And we fill up, let's call it the left node, right? This will return us some kind of node, like, okay, it will either be an immediate at the moment or it will be a keyword or whatever, right? If the left node type is this is hard to think about. I should have thought about this a little bit more before the stream. But no. Let's just jump right ahead. So excuse me, I have not planned this at all or thought about this at all. First, it's also my first time I'm doing expression trees like this, so this will get messy. Just so you'll be warned. Okay, so this is a terminating node, right? You have an immediate, there can't possibly be anything else. Right, so you can have an operand, right? If it is an immediate, then that operand is done. So an operand is then followed by a separator and then can have another operand, right? And you can have that repeating, right? Like so. Okay, parse expressions. So let's say we have let's call this left. And we say parse node. Tokenizer current token and left. Oh, come on. So I'm wondering how I should do stuff like this. So let's say, for example, I have a register and say +1, right? This is illegal. Like this cannot happen. So do I now just parse it as, you know, a possible syntax and then verify it later? Or do I already verify while going through this? I think I should do it later, right? I'm just building the tree, basically. And then I can later go through the tree. So really, in the end, I do not really care what's on the left side, right? I just need to get the left side. So do I then hold on to the entire token because it has the value? Maybe I should, because the token also has, you know, all the information of line numbers and this kind of stuff. So if there's a syntax error, I can then say, hey, this string on line so-and-so, column so-and-so, byte position so-and-so is unexpected. What we wanted is an identifier, right? So it kind of makes sense to hold on to the tokens. So instead of this, just having the tokens there. These should probably go into the Alexa. So token type binary, token type hexadecimal, and token type decimal. Well, and potentially an identifier, but oh my god. Okay, 1 hour left. Is token keyword, I suppose. Does that make sense? I mean, why not? Okay, so these keyword types are all instructions, right? But there's other keywords types which I haven't added yet, and those are sort of all the registers and stuff. Like these. And I wonder if I should add this information to the generator or not. But I can worry about that later. Basically what I need is like, is this keyword a register or not, right? Or a condition. No, a register. Let's call it an operand keyword. Because the other ones are instruction keywords, right? Yeah, just keyword. So I guess let's add them. Right. Where was it? just copy these. Put them in here. I think keyword type, yeah. And this goes in here. What? Right, I didn't save. Okay. Okay, with identifiers, there will be certain rules, I suppose. I won't let users allowed to create aliases for known keywords. So you wouldn't be able to do a alias, I don't know, my a right? At least not for now. Maybe I can if I try to resolve them already. We'll see. Okay, let's just say it can be a value or an operator, right? And value can either be an immediate or whatever. It is just a value, right? then here, I think what I'm going to do is say the exact token. All right, let's just take a copy of it. And if it is an invalid token, I can just treat it as a value. Perhaps. Okay. So do I even need my brain does not work today, honestly. I think this was actually okay. We have a token and we're trying to make a node out of it, right? You want the first node basically. So how do I deal with invalid nodes? I'll just say token type value because like that is a single thing, right? A value is a value. And then I can assess the value, right? That is the final node basically, like the node. So, and then token types. So we're not gonna have, no, well, we do gonna have these. We're not gonna have white space or comment, right? Those we filter out. Everything else we can have. But we're just gonna focus on maybe I should put it in the memory arena. Okay. Should I? Yeah, that's okay. Right. Results, arena. Okay. I even named tokenizer, even though I no longer have a tokenizer. Jesus. Okay. We pass in this, and what we return is a node t, right? Yeah, parse node. That's fine. Okay. So then we have Lexa is not 0. Okay. We are getting the current token, right? So token t, token, let's name it current, is Lexa current token, right? Probably don't have to do this, but might help. So we want to figure out what this is, right? So we're gonna do current type, and if it is this, right, we're setting it to a value. We no longer have the immediate, we have the token. In any case, what we want to do is say node well, we want a new node, right? So node t result is get memory arena type Lexa arena, and we want a node t. Right. Okay. So decimal, hexadecimal, binary. Okay. Identifier might have to do something there. So this is a value with left and right not specified, and node token will be Lexa current token. Right. I wonder if I even need this node type at all. Because I can figure out what it is based on the token. And whether it is the, a value, the terminating node, I already know that because left and right will be a null. So I don't think I need this at all. Um, so the only invalid things I have to worry about are these, right? So really, if we have any of these, then I should not continue parsing. Because, well, with invalid, I might have to. But not with new line or end of file, because that just means we are done. Right? So okay, let's do it this way. So if end of file and new line, then we just stop, right? So we can just return null because there is no node. We're done. I can still say Alexa advance. Okay, I have to figure out where to advance, but essentially, okay, so we reach the end of the line, or new line, or the end of the file. We are done, right? We just return null. We're not going ahead with anything. What happens with invalid? So invalid means like, okay, there is a number like a hexadecimal or whatever. It's ill-formatted, right? It doesn't make any sense to use. In which case, we have already put an error from the Alexa on the error list to be printed out at the end. But because of that, it means the whole line is essentially bogus, right? It is invalid. So in this case, we probably should stop altogether, right? So we can do that as well, except there might be more tokens after it until we get to a new line. So really what you want to do is read until new line or EOF. So, let's do that. Do I have something like this? I only have Alexa Advance. Okay, let's add it. Okay, so Alexa skip to next line. We're just going to skip all the tokens until we reach a new line, right? So or end of file. Switch Alexa, no, while is token binary operator, is token immediate value, is token operand keyword. Okay, let's do is token end of line. And this is token type case token type end of file case token type new line. Right, I called it new line, I think. Yeah. Okay. Return B32 true. Default B32 false. Is token end of line. So this will make this code a bit nicer. While is false. Alexa current token. Alexa advance. Okay, as long as we do not have an end of line or end of file token, we're just gonna call Alexa advance. There we go. So now we can here say, okay, we reached an invalid token. Let's just forget about the whole line. We don't care, right? So skip to the next line and then we try again. So we will just return null here. Now with everything else, we probably just want to return a token, right? So, sorry, a node. So we do Alexa arena for a node, have a result. If it's not null, we set left and right to 0. Right, and then just say, well, this result also has the current token. And then return result. And if it has the current token, we can probably say Alexa advance, right? Because we consume that token, we want to get the next one whenever like we do a next call into this. Okay. So this is a parse node. But there's, of course, a bit more to it, right? Okay, so for parse expression, right, we need to parse the left side. And I'm not quite sure how that would look like yet, because like a left side can also be something like this, right? So, so 1 times 2 plus 3 times 4, right? So this would be the root node essentially, right? This would be left. This would be right. So we parse that node. And then what you want to do is pass to the right depending on precedence. So I need more water. And precedence essentially just becomes a number, right? So let's say you have a U32, right? We set this to U32 max. That is our starting precedence, right? And you basically decrease the precedence as you encounter these operators, right? So so parse expression. So in this instance, we pass in a node that we already have, right? Let's just call this left. Let's assume we have a left side. I don't know how we do this yet, right? But let's just assume we have a left side. And what we then need to do is continue on from there. So then we can say, well, we have Alexa Advanced, so we can get the current token, right? Token T. Actually, don't even need to do that. If token is if the current token is not a binary operator, then we are at the end of the expression, right? So if we have 1 comma or whatever, we're done. One plus one, so we continue here. It is a binary expression. We do whatever we need to do right here, right? And then we go up to this point where at some point we then check, oh, no, and it is not. Okay. Could also be any other token, doesn't really matter. It could also be another number, which, illegal syntax, but that's not what we're checking right now. We're just checking expressions, right? So we have one expression followed by another expression, right? So those would be 2 expressions. And if they're not separated by a comma, that is a syntax error, right? You would have to do something like this. But that will be reported once we go through the whole tree, right? If it is a binary operator, then we need to do something. No shit, right? Maybe I do need to have a parse binary. No, I don't. So if this is a binary operator, I just need to continue with parsing the right side, right? So essentially calling parse node, but that's not quite right. Parse node is not quite right at the moment, so I don't know if I want to call that here, right? No, you call. No, this is one level down. At this stage, I could just look it up, but I don't want to. I really don't want to. I really don't want to look it up. I really don't want to. I think parse expression is more on the top, right? So here we would say let's call this parse binary operator, right? So what we would do is node t parse expression, right? Good afternoon. Yeah, working on the parser, on the trying to parse expressions. Like 1 times 2 plus 3 times 4, for example, right? Never done this before, so I'm struggling a lot right now, but I'll get it eventually. It just takes ages. And because I'm stubborn, I don't want to look it up, so I just want to try and figure this out for myself. I do remember a little bit from a video that I watched about this, but not enough, it seems. Okay, so right, we want a left side. Yeah, exactly. It was about pred parsing. Pred parsing and precedence. It was one of Jonathan Blow's videos, I think. At one point, I might just bite the bullet and rewatch the video and continue with that. I mean, I could just do it top down, to be honest. But So okay, I'll just do this, right? Let's just pause the first the left node, right? And then what you want to do is parse the binary operator, right? So we're parsing the node that will advance, and we pass in left. If this is not a binary operator, we're done, right? This will give us a new node. If this node is the same as the left, we are done, right? So we can just return left. We're just having this. But then as binary operator continues, it probably will no worries. If I really want help, I ask for it. But like, I just like trying to figure it out for myself. But I know that's not the most exciting thing to watch if just someone sits here and struggles and thinks about it. But you know. But it is what it is. Okay, so we're gonna continue this route, right? So let's think about what this thing will build, right? Okay, if we let precedence, like forget about precedence for now. 1 plus 2 plus 3 plus 4, right? Easiest case. So we're going to pass into expression. We're reading this node, right? And then we want to assume this is our left for the tree, and we try to read the binary operator, right? Whatever it is. If there, yes. If there is none, if we just had a number, then we're done, which is this case right here. We're returning left. But otherwise, we go into parse binary operator, right? And if we have a binary operator, okay, we do have one. We now need to read the right side, right? And the right side, well, what is the right side, really? The right side is just the left side of the next expression, right? So 2 plus 3, right? So, and then again, we do the same thing, and then we end up with 3 plus 4, and then just 4, right? So really here, if this token is a binary operator, we want to read the right side, right? So that would be node T, right? Which is an expression. Okay, but this is a binary operator, so I kind of need to prepare things a little bit, right? So what I need is a node, which is just that token. Yeah. So, no, actually, yeah, no, I do need it. Right, and this will get the current token type, again, do its thing, right? We can assume that it's not null because we passed this check right here. So I'm not going to do a null check here. I mean, we can do an assert, just for the debug mode for now. That's all right. Okay, and then we just, this advances to the next item there, which would be the 2, right? So we just call parse expression, which goes in here. So it reads this node, right, as a 2, and then tries to parse a binary operator, and so on. I probably have to rename this to something else, but, you know. Okay. Now, right could be null in this instance, right? Is that a problem? Probably not. I should plug in a few more asserts though. Okay, anyways, let's just look at this case, right? So 1 plus 1. Parse expression, this becomes the left node right here. We pass binary operator, which indeed it is, so we create an operator node, right? Then we pass the right side, which goes again into here, left, right? We pass the binary operator, which is not a binary token, so we just return left again, which will just be the 1 right here. Oh, I should make it a 2. So, which will just return the 2 here, right? So this left becomes this right. And then, essentially, what we can do is just say operator. Left equals left. And operator right equals right, right. And then return the operator. And I mean, for now, I can just return left in general. Right? So I can just say left and return this. But from what I remember with precedence, we'll get to that. Okay, so do this left. Right. Pass binary operator would then return this with this as left and this as right. Right. I think that's okay. Okay, I don't handle commas or anything like that yet, but let's just plug this in and see what happens, right? So hang on, parse expression called parse node. Parse node does this. If something is invalid, skip. That is fine, because we already have arrows for those. And then it calls Lexa advance. Okay, so by the end of it, should be done. Okay. No, hang on. Hang on. If it's invalid, I also return null, which is suboptimal, really. Let's get rid of all of this. I just need some output so I can break on it. Okay. There we go. Right. What? What are you on about? I'm looking in the wrong file, aren't I? So is token end of line. Is token end of line. Right, that needs a pointer. An address build. Right. Parse expression undefined. That is a parser. Parse expression, yeah, that would be correct. Okay. Right. I'm no longer skipping comments and all this kind of stuff. Yeah. That was annoying. Oh, hang on. Yeah, I don't. So parser, where is advance? Lexa advance should be wait, what? It already does, excluding white space. So what are you doing? Oh my, I screwed that up, didn't I? I think my brain is proper mush right now. Okay, I need to see what's happening. Because I can't figure it out by looking at it right now. Okay. Right. Token type is new line. Okay. Whatever. Right. Parse node. That would be 0. Why is 0, boy? Because so either one of these, huh? Oh, because you're a new line. Ugh. Okay, I need to do it a bit differently then. Fine. Okay, while token, actually, let's just copy this, right? Yeah. What? Yay. Okay. Actually, let's just do right. That is enough for me to like break on. Okay. So now, like this. Okay. Okay, it can recognize that. And it can also recognize this. Okay, cool. Now let's see. Didn't have to rebuild this, but whatever. Should have removed these. Okay. Right. So token type plus, right? This is the first one right here. That is line. No, it's line 11. Right, this one will just return 0. Okay, whatever. Okay, right is token type decimal with 2. And left is token type decimal with 1. Okay, cool. Now, what if I have nothing? Well, that works. I expect this one to be zero. Okay, so expression plus. Left is just going to be a decimal. Right is going to be another plus, right? With the left of 3. No. With the left of 2. Sorry, this 3 confused me. With the left of 2 and a right of plus, right? And that has a left of 3 and a right No, what am I? No, I was looking wrong. Oh my lord, this is confusing. Right, with the right of plus and the left is number 4. There we go. I went up to 5, right? So right then is plus with the left of number 5 and right being 0 because that is the end of the line, which I just have as token type end of file. But that's all right. We're just looking at one line at a time anyway, so okay, well, at least it can do that. That is great. Good stuff. But also, what I should do is what? Oh, because you're still running. Okay. So, of course, this will not print an error yet because we're not validating the expression tree yet or anything like that, right? I just want to make sure I can actually read it. But okay, so this so far worked. And now, just need to make precedents happen, right? Because right now we don't care, right? So we could do 1 plus 2 times 3, right? No, other way around. One times 2 plus 3, right? So here, yeah, so in this instance it would do the right thing, right? It would essentially be the same as doing this. But here with the parser, at the moment, what it would do is 1 times 2 plus 3, essentially. Because it sets the plus as the right node for this, which is not what we want, right? What we want is this. And what I have to figure out now is, I kind of sort of remember how it works, right, from reading some of this and watching some videos, but so left, and this would become right. Okay, but here we want this to be left of this. So this is where precedence essentially comes in, right? So you can give each of these operands, sorry, a sort of weight, right? So this would have a higher integer value than this. And then you can, as you pass the tree, you go as far as, basically compare the precedence value of this to this, and if this one is lower than this, the integer value, means it has a higher precedence, right? So you essentially stop. So this just becomes the right instead of this. Right? So, and then you have this node right here, which is your new left for this operation right here. So let's say we have a U32 precedence, right? Is that how you spell it? I hope so. Nope. Precede. Oh, for precede. Man, as a non-native English speaker, this is sometimes weird. Anyways. So in the beginning, we can just put in like U32 max or something, right? Because you're just starting out, essentially. We don't have an operator yet, so we don't know what kind of precedence we have, right? It's just... And then if we encounter M+, we change this to whatever plus has, right? And then as we go down, we basically just compare this value and change it to whatever the precedence of this one is. Okay, so I probably have to pass it in here as well. Because that is the starting precedence, right? And this is where you sort of start looping, because now let's assume this is done, right? So we're going to go in here, and we're actually getting just this chunk out of here, right? So this would be our new left. So node T, let's just say node, right? Then we still want to pass the rest of the expression, because there could be stuff following it with a different precedence again. So what we then can do is say yeah. Do no, I can't do it that way. Oh, bastard. Ah. I can't do it with a do while. Yeah. So if the node that we return is the same as the left that we passed in, then we're done. Right? So we can break out of this. If not, then the node we just returned becomes our new left, and we start pass binary operator again, right? So we're parsing this, checking the binary operand. We know this has a lower precedence than multiplication, right? So we return this as the new node. But then we need to continue with the rest, which means this node that we just created becomes the left side of the next binary expression. Yes. Okay, cool. Cool. I don't like this while true like this, but okay. Can this left ever be null? No. It shouldn't. It should not be possible. Okay, so I do not need to have a null check. But, okay, I can make this ugly by doing it like this. While node is not left. So if node is equal to the left that we passed in, then we're done, right? So we're breaking out of this loop and just return left. Otherwise, we just assign node to left and then try again. Okay. Cool. So pass binary operator, we now have a precedence, right? So we check if we actually have a binary operator, and then we need to figure out the precedence of it, basically. So what we want is probably have something like Q32, get operator precedence. Yeah, let's just take in the token. Right, just the current token, whatever, it doesn't matter. And then we can just say token type. Well, and then basically depending on the token type, we can return like a precedence, whatever. Just encode it as a switch. Why not? Okay, let's start with add, right? So that will return something. Why is this so weird? (2004), yeah, maybe a bit earlier, I don't know. Okay. Whoops, this should be token type. So I don't know, doesn't really matter what we do, right? Let's give it a 3 or whatever. Oh, most of your usage was around that time. All right. 2004. Let me think. Have I been doing C then? Or was I already on C sharp? I don't remember. Dang. Svenska? No. Nope. You have a few more guesses. Nope, nope. Let me put it this way. I live in the UK, but I'm not from there. No, so if you're hearing an accent, it is probably German. Though, according to Germans, I sound like a Canadian. I can't verify if that's true or not. To me, Canadians sound very different. But every time I'm in the airport in Germany, they're like, "You're not German. Where are you from?" I'm actually like, "Nah, I was actually born in Germany. Thank you very much." But more Bjork than Schnitzel. All right. To be honest, my language or speech pattern is probably all over the place, anyways. Like, I've been told some of my words sound a bit American sometimes, which probably comes from watching American TV shows as a kid. But all right. All right, so divide and multiply, higher precedence, so we decrease the number, right? And I'm not worrying about the other ones just yet. I'll probably just look at the C precedence and sort of try to do the same thing, instead of trying to come up with my own things here. But like, yeah, let's just say the numbers really don't matter, right? You just want to return something, right? I mean, we could make a default and say, yeah, I don't know. The rest just has a default of 4 or whatever. It doesn't really matter. How many instructions? I don't know. There we go, 44. Not counting all the variants between the operands, obviously, but like, I think in total 100 something. I don't know. I would have to look up in the Game Boy manual, to be honest, but actually maybe GB Dev does know. GB Dev IO. Is there like a count? I don't want to count. I'm too lazy. But yeah, there you go. Those are all the instructions. Welcome back, Divine Fox. All right. Assembler and disassembler. Nice. Yeah, I'm not implementing macros or anything. I'm just doing basic arithmetic and stuff for like a few things. Essentially just like for these things to calculate count between like labels and stuff. That's essentially it. And then I have some predefined sections that are well known within Game Boy games and stuff like that, for example, where the header lies and things like that. No, I'm assembling the textual representation here. So I have the assembly code here, and then just trying to make the bytecode out of that, essentially. And like, I'm not well versed in C, right? I've been mostly doing C# back in the day, so I'm learning basically C more or less. I should say relearning, because I kind of started out with C, but then, yeah. And I always was curious on how to write development tools and things like that. So I thought like an assembler for a relatively simple CPU would be nice. And I also want to learn assembler, and I also really want to write a disassembler. That will be fun as well. Yeah, parser and indexer in C, and without the C runtime. So no C standard libraries at all. Yeah. Okay, I think this is the last thing I'm gonna try to do today with the precedence, to see if I can sort of get something right with it. It's chaos at the moment, I know, and it took me a long time to get to this stage, but it is what it is. Okay, so here then we can say, right, we know we have a binary operator, right? So we can say get operator precedence from the Alexa current token. Right, and if Rust, yeah, I tried a bit of Rust when it was fairly new still, and I liked it at first, but then it kind of went insane, so I stopped using it. And by that I mean they added too many features for my taste. You know, it's just I like simple languages, and Rust kind of went in a bit of a different direction. Books and articles on the subject. What kind of subject would you like? Without C runtime? Not really. I made a YouTube video about it, which has very shitty audio though, so I can recommend that. And Parses Lexus, I don't really have anything yet. Like, I mean, a lot of the things people usually quote is like crafting interpreters. This one by Robert Nystrom. It's free, like on the web. So you could use that, or there's bits and pieces of fragments of like Jonathan Blow videos and what he's doing with his language, so you can learn a few things there, as he's mentioned. But it's kind of hard to find because he's not doing tutorials on it or anything like that, right? It's just snippets here and there. And other than that, yeah, I don't know. I don't really have that many good articles or books on this topic, so I think the best thing is just don't worry about it and just try and wing it. See if you can come up with something yourself. I mean, understanding tokens is like the most basic thing, right? Just try and write Alexa reading tokens, and then just parse the tokens, and yeah. And the good thing is, if you do it that way, if you just try and not worry about like what other people have been doing, you kind of learn a lot, and then you know what you could write better or different the next time around, when you have to write a parser again. Or you're like me and you scrap your whole old project and try to rewrite it, which is what I'm essentially doing, because I did not like my first attempt at all. It was horrible code. Yeah, so all these generator languages and stuff like that, I don't like that at all. I I don't know. I don't like creating a parser out of something like, what is the Bacchanauer definition, or how do you call that? I don't even know. Or something. Bacchus-Naur form, this one. Right, because you're kind of writing in a different language to try and define all the rules for your language, and then you have a generator that generates all this code for you, and then you kind of, the error messages are kind of going to be shit as well. Writing it by hand takes a lot longer, but it's fun. I like having fun, so fun. I mean, to me, it is fun. So, yeah. I'm not sure you can drop links in the chat, to be honest. I think I have that disabled. Nah, it didn't work. But it's alright, don't worry. I'm really bad with looking at that stuff anyways. Okay, I almost streamed for 5 hours, so let me try and get this done, and then I'll probably quit for today. Okay, so if the precedence is smaller or equal to, hang on, no. If the new precedence is smaller or equal to what we're already at, no. Hang on. My brain is not working right today, honestly. Okay. Let's say I have an add here, right? Add would be precedence, I don't know, 3, right? And now we encounter this, which has a precedence of 1. Now let's do it the other way around. Right? So we have a precedence of 1. And we encounter something that suddenly has lower precedence, so the number is higher. That means we want to stop. So if it's not no, the numbers are the other way around. The lower the number, the higher the precedence. Yeah, I know, it's a bit confusing. I mean, I could change it. It's fine. It doesn't really matter which way around you do it. Okay, let me think this through. So I have a precedence of... So at first this will be uint max, right? Uint max is not small or equal to whatever that will be, right? So we do this. Let's say this is 1. The next one will be the plus, so it will be bigger, right? So this is smaller than that. So let's just return left. Okay, but what if... So, hang on. Do I just need to do that? Or what if they're equal? No, equal is fine as well. Okay. I think that's okay. Okay, and then here, U32 max. Okay. Token type. Oh, did I name it minus? Okay, fine. Okay, cool. So now this is what we expect. You know what? Let's do 1 plus 2 times 3 plus 4, right? And then we can have 2 times 3, 1 times 2 plus 3 times 4. Just switch it around a little bit, right? So what we're expecting is 1 plus 2 times 3 plus 4, right? And here, 1 times 2 plus 3 times 4. I don't think that will fully work yet, but we'll figure it out. And we want to break here, right? Okay, you know what? Let's make sure they're on the top of the file. Right. Whoa. Okay, so the first expression, we have token type plus. Okay. The left is a decimal. And the right is a multiply. Okay. Is that correct? The left is a decimal. No. That is not correct. Okay, I have to draw this out for me. Hang on. I'm just using a piece of paper to like draw this out for me because that helps me think about it a bit. Okay, and let's do the other one. Okay. Where is the debugger? Did I close it? No, there we go. Okay, so so the first expression is the plus, which is correct. The left should be 1. Yeah, decimal number 1. Okay. The right should be, it should not be a multiply. It should be the plus. Okay. Because now the right side of the multiplier becomes the, yeah, that is wrong. Unless I'm confusing myself here, but okay, let's look at the next one. So this one, am I confusing what the tree should look like? Yeah, that's wrong. Okay. What about fine, let's do it this way around, right? Basic case. Oops. There we go. Nope. All right. Well, I screwed something up, so I probably have not thought about this properly. Surprise. I might have confused myself. Actually, let's step through it. Right. It's the first expression, right? Well, you can't. Okay. How about now? Now you can. Okay. Fine. Okay, so this is uint max for now, right? We're going into parse node to get the left node. The left node now is a decimal of 1, which is what we want. Okay. So we go in here and go to the parse binary operator with that high precedence right there. The left is the decimal. Okay. We check if the current token is a binary operator, which it will be because this is a multiply token. So we are here. Now, a multiply token has a new precedence of 2, right? So what we're going to do... Hang on, how did this work? Oh! Oh, dear. Dear me, dear me. I love C. So, it kind of worked, but it didn't. So, this needs to go in here, right? And then here, we need the new precedence. Okay. Right. Now we can have a look. Okay. Now this looks more like it. Look at that. Token type plus. And the left side, it should be... What? Did I skip the first one? Because if not, I'm thoroughly confused. Multiply 1 and 2. That's not... Oh, hang on. I was looking at my little paper trees right there. You know. But I added this one. Okay. Panic over. Okay, so we expect a plus. Okay. With the left side being a multiply of 1 and 2, right? So number 1 and number 2. And the right side being a decimal of 3. Okay. Yep. Okay, now we have this tree right here on my paper. Cool. So a token type of plus with the left side. I think I mixed up left and right side on my little thing, but that's all right. That's all right. The right side being a decimal of 4. Okay, this is not where I thought this would be going. Oh, it makes sense. Okay, we're building from the other side. Okay. And then a token type of plus. Again, with a decimal of 1. Yes. Fine. I have it the other way around on the paper, but yeah, it makes sense that we're going from the last one. Okay. Then we have a right side, which is the multiply. And that is gonna be number 3. And the left should be number 2. Yes. Okay. And then the last one. We're having a plus. That so far is correct. And then left and right should be multiplies. Yes. And this should be multiply 1 and 2. Fantastic. And the right side is multiply 4 and wait. What? I confused myself. Is 4. And this left side is 3. Okay, cool. Well, that works. Sweet. Yeah, I'm gonna stop now. Over 5 hours. Oh dear. Okay, well, I'm kind of happy with this. It took me a long time to get to this stage because my brain just didn't fire up today. I just should have spent a bit more time before stream to actually thinking about how I want to do this, but here we are. Yeah. And now, so the fun part will be, I mean, since we have operator precedence, we can probably deal with the other ones quite easily, but the next thing would be like and or x or not, left shift, right shift, and unary operators, are they called, right? So plus and minus for numbers, right? Then we need to kind of figure out how to do braces, right? Because I support those as well. And that will be parsing of an operand, right? Now, operands are separated by separator characters, so I have to kind of figure out how to do that. And then, yeah. So there's still lots to do, but at least multiplication, division, and stuff works, which is great. I like it. So let's make a commit. Right. What did I add here? Oh, right, I added those. That should be a separate commit. I mean, I don't really need to check in those two files, to be honest. But sure. And this has nothing to do with that change. Okay. Adding keyword definitions for registers and condition operands. Right, git push, and it will fail for now. Okay. Whoops. Now Lexa. Really? Lexer C. So this added some convenience methods, which I don't use them all, but oh, come on. I hate that tab doesn't work. Does it work with the... Oh, okay, I can't use forward slashes. Fine. Wait, why did I add the parser? No. Okay. And then we do the last commit. Adding parsing of expressions with precedence. This word, man. Okay. Cool. Is it all here? Yes. Nice. Okay, cool. I'll leave it for here now. I'm gonna continue this on Wednesday morning, whatever time that might be for you. So usually 10 a.m. UTC time. So, and probably for another 4 hours or something. Right, cool. Thanks for watching, and see ya. Bye. Now the awkward fiddling until I find the end scene. There we go. Bye.